Hello friends, welcome to Susan and John MathTube. This is the second video lesson in the examination preparation series. And these videos are meant only for the first year engineering students who are doing engineering in Tribune University affiliated colleges. Anyway, let's continue with partial differentiation. Yesterday we went through partial differentiation and today we will be learning the applications of partial differentiation. Of course, it's exam time, so it's without proof. So the first application is to differentiate implicit functions with the help of partial differentiation. I'm sure you learned how to differentiate implicit functions in your class 11 or 12. But it was a long process. But with the help of partial differentiation, we can find the derivatives very easily. And let's say there is an implicit function f of xy equal to 0. That may include constant, but I have not included it over here. And it's in two variables. Then the derivative is given by minus fx by fy. Those who have watched the first lesson will understand what is fx and fy. Fx stands for the partial derivative of f with respect to x, and fy stands for the partial derivative of f with respect to y. Like I told you yesterday, I hope you have a pen and a paper and make sure you note these points. So let's move ahead, and the second application is total derivatives. And let's say we have a function u, and u is a function in two variables. For example, u is equal to x into y. So we have a function u which is given in terms of two variables, and let's say x is given in terms of t and y is given in terms of t. So take a look at this. U is in terms of x and y, and x and y are defined in terms of a variable t. In such cases, we will be able to find du by dt very easily with the help of partial differentiation. And the formula goes like this: du by dt is equal to, the partial of u with respect to x. I have put some additional arrows over here, and the ordinary derivative. Okay, look at this. The trick is very easy. The blue line is what exactly we are going to find. And if you see that the arrow is pointing towards one variable, then we will write ordinary derivative. If it is pointing towards two variables, then we will write partial derivatives. And if you are able to write the first term, then the second term is very easy to write. Just replace x with y. And this formula can be extended to any number of variables. Okay, now the second one in total derivatives. You suppose w is a function in x and y, and x and y are defined in terms of u and v. Then look at this. Like I told you before, the blue arrow points towards what exactly we are going to find. And I can see that there are two variables, so we are going to find the partial derivative of w with respect to u and the partial derivative of w with respect to v. And the formula goes in the same pattern, that is partial derivative and again partial derivative. Okay, moving ahead, let's go for the last application, that is total differential or the differential. So suppose you have a function u which is in terms of x and y, and if you want to find the differential, you just use this formula. And suppose u is a function in three variables, just extend the formula. So I hope you're noting these things down in a paper. Okay, anyway, it's better that you take a screenshot of the next page so you can see all the formulae. Okay, done with the screenshot. Let's start with some problems. Okay, now look at this. We have an implicit function. Implicit function means all the variables will be kind of like mixed up. Okay, so if you have an implicit function and if you wish to find dy by dx, then partial derivative is the right person to help you find dy by dx. So look at this. The first thing you have to do is take all the quantities to the left or right according to your convenience. I find taking minus a cube to the left side profitable and call it f. The next thing to do is you find the partial derivative of f with respect to x. I hope you remember fx stands for the partial derivative of f with respect to x. That is, you differentiate f by treating x as the only variable. So the derivative will be 3x square plus 3ay into 1 plus 0 minus 0. Okay, now find the partial derivative with respect to y. That means y is the only variable. So we are going to get 0 plus 3a x into 1 plus 3y square minus 0. Now the formula. I hope you had a screenshot of the formula list. So find the formula for dy by dx. Yeah, that's it. So take 3 common and cancel. Here we have the derivative. Okay, now let's move ahead. Let's try a slightly complicated question which you might have learned under logarithmic differentiation. If you remember your class 11 and class 12, it will take at least 1 or 2 pages to evaluate the derivative of this function. But today, with the help of partial derivatives, you'll just enjoy finding dy by dx. Anyway, I will keep the question over here. So tell me, what's the first thing to do? Okay, take all the quantities to the left or right as you wish and call it f. Okay, now before we start, let's discuss some formulae. So take a look at this. What is the derivative of x power n? I'm 100% sure most of you know the formula n x to the power n minus 1. But please be aware, x stands for variable and n stands for constant. Or rather, this formula will be applied when you have variable to the power constant, something like x to the power 9. Now, if it is n to the power x, that is something like 3 to the power x, or maybe 5 to the power x, then the derivative is given by n power x ln n. That is, the derivative will be, you just copy the same quantity and then you put ln 3. And this ln stands for the natural logarithm. If you don't want to write ln, you can write log to the base e. Okay, so let's read the question once more. You want the derivative of this implicit function. And the actual procedure is you'll take logarithm and make it implicit and differentiate for a long time and extract dy by dx. But now, with the help of partial derivatives, what we do is we find the partial derivative with respect to x. So look at this. When you find the partial derivative with respect to x, always remember x is the only variable. That means y is a constant. I'll repeat, x is the only variable and that means y is a constant. Or rather, it looks like variable to the power constant. And that is why the derivative looks like this. And now take a look at the second part. Y is a constant and x is a variable. So it looks like n to the power x. And hence the derivative will be y power x. You just copy the same thing and ln of the constant. And what will be fy? Fy means the partial derivative of f with respect to y. And that will be x power y ln x because x is a constant and y is a variable. So constant to the power variable which is n to the power x. Okay, that's it. Now write the formula for dy by dx and substitute. That's it. That's it. It's so easy. Okay, now let's move ahead. Suppose u equal to x square plus y square, where x is equal to 80 square and y is equal to 280. Please notice that u is given in terms of x and y, and x and y are given in terms of t. Unless otherwise specified, a will be treated as a constant. So they are asking you to find du by dt. Okay, let's make a picture. So I have kept the question on the right side of the screen. Okay, now look at this. U is a function in x and y. U is given in terms of x and y. And x and y are given in terms of t. So, like I told you earlier, look at the blue arrow. This is exactly what we are going to find. We are going to find du by dt. And if you want to know the formula, it's very easy. The arrow is pointing towards two variables. So I'm going to write the partial derivative of u with respect to x. And then this arrow points towards a single variable. So I'll write dx by dt plus, you repeat the same thing with y. Okay, so there it goes. We have the formula over here. This stands for the partial derivative of u with respect to x. So I will check u. And what is the partial derivative? 2x. And for this, I have to check x. I want the derivative of x with respect to t. Ordinary derivative. Yeah, so I can find the ordinary derivative from here. And that's it. So 2x and a into 2t plus 2y and then 2a into 1. And remember, the answer must be completely in terms of t. So I'm replacing x with the value of x given over here and y with the value given here. And simplify. And finally, if you want, you can take common, and that's it. This is the answer. So let's try one more question, and that's very important. Please make sure you put some star or something. So this has been asked many times. So let's say u is equal to sine x by y, and x is given by e to the power t and y is given by t square. So we can draw the picture. U is in terms of x and y are in terms of t. So I have to complete the question. So we are going to find du by dt. Okay, so let's put the question over here and then the graph. So look at this. U is in terms of x and y, and x and y are given in terms of t. Now let's write the formula. and I'm sure that you're pretty good with this formula. So du by dt. So how do I find this? I have to look at u and differentiate it partially with respect to x. And how do I find this? I have to check x and differentiate with respect to t. The same thing for the second term. Okay, before we start, take a very good look at this. What is the derivative of x with respect to x? That is 1. So if you differentiate 5 into x, the answer will be 5 into 1. And if you differentiate x by 5, what happens is this becomes 1 by 5 into x, and you get 1 by 5. Okay, so I hope you're clear with this. And one more small thing and we can start. Okay, the derivative of 1 by x is minus 1 by x square. So if you differentiate 5 by x, which is actually 5 into 1 by x, gives us 5 times minus 1 by x square, or minus 5 by x square. I'll make it more clear. If you differentiate 3 by x, then the answer will be minus 3 by x square. So let's move ahead, and I have kept the formula here. Then look at this. This is something very, very important. The partial derivative of u with respect to x. So u is equal to sine x by y. I'll repeat. U is equal to sine x by y. So the partial derivative with respect to x, it's given by sine something, that is cos the same quantity. You copy the same thing. And then x is the variable, so it's going to be times 1 by y. That is how we got this term. But at the same time, here you are finding the partial derivative of u with respect to y, and that means y is the variable, and that is why you got this. Okay, let's move ahead. Yeah, there's something common over here, and I told you the answer should be in terms of t. So I'm replacing this x, y and all those things with these quantities, and you can take LCM, you can simplify a little bit, and we get. So let's move ahead. Okay, now let's say u is equal to f of xy, where x equal to r cos theta and y equal to r sin theta. Yeah, in lesson 1 we saw these characters, the substitution which takes polar coordinate points to the Cartesian coordinate points, or just shows that there is a connection between the polar and the Cartesian system, and prove that. Wow, we have to prove this. Okay, let's try to draw the situation. So u is in terms of x and y. It's clearly mentioned. It's not, the function is not given. U is equal to f of xy, and x is in terms of r and theta. Same thing for y. Y is in terms of r and theta. So I'm going to write this x and y are in terms of r and theta. So tell me, what exactly are you going to find? I'll draw a blue arrow. Yeah, we are going to find the partial derivative of u with respect to r and the partial derivative of u with respect to theta. And that is exactly the quantities which we see on the right side. Okay, let's move ahead. I'll put the question on the right side of the screen so that you can refer anytime you want. And I'll draw that diagram properly. So as I told you, u is in terms of x and y, and x and y are in terms of r and theta. and the formula. Okay, I hope you're pretty good with the formula now. But remember, all these are partial derivatives. So let's start. It's really easy. Look at this. U is given as a function in x and y. The function is not mentioned. So you're never going to find the partial derivative of u with respect to x. So keep it as such. Keep this as such. But the partial derivative of x with respect to r, you can evaluate it very easily. It will check x and differentiate with respect to r. So who is the only variable? R. So that will be cos theta, sin theta. I hope you're okay with the step. Now let's write it here. I lack space. Okay, I see something common, so I took it outside. I just took minus r outside, so in between it becomes minus. Okay, that's it. We have the quantities on the right. So let's start with the right hand side. So there it goes. I have the right hand side, and instead of partial derivative of u with respect to r, I'm going to plug in this value, and instead of partial derivative of u with respect to theta, I'm going to plug in this value. I know this is negative, but when we square, it's going to be positive. So let's forget about that negative part. And this is exactly what you're going to get. And we can cancel this. And what is a plus b the whole square? Yeah, a square plus 2ab plus b square. At the same time, what is a minus b the whole square? A square minus 2ab plus b square. So I'm going to apply those formula. I hope you're okay with this. You can take your own time and work out these problems along with me. Okay, I'll write it a little bit clearly over here in a single line. Okay, we can see that this and this will cancel out. Now I see some common factors. Okay, this one and this one, and again this and this. So I took common, and what is cos square theta plus sin square theta? It's 1. Okay, so we reach the left hand side. That's it. Now let's go for another question, and this is a very important question. This is from your past paper questions. Given z is a function in x and y. The function is not mentioned, and x is in terms of u and v, y is also in terms of u and v. Prove that. Okay, wait, to prove this, and I'll repeat, it's important. I have seen this question in the past papers, so let's try to make a picture from this question. So look at this. Z is a function in x and y. So I'll write Z being a function in x and y. And x and y are given in terms of u and v. So I'll write u and v. And for your benefit, I'll take blue color and I'll mark like this. Okay, so tell me, what exactly are you going to find? Yeah, the partial derivative of z with respect to u, and also the partial derivative of z with respect to v. Okay, and that is exactly what they have in the left hand side. So let's start. And as always, I'll keep the question on the right side of the screen. If you want, you can read it once or twice. And let's start. So we have a function in xy and xy in uv. So we're going to find this and this. Okay, that's it. So I have the formula. Okay, now let's start. Now look at this. Z is a function in x and y. That is all we know about Z. We don't know the function. So you're never going to evaluate 1, 2, 3, 4 quantities. You're going to keep those quantities as such. But the one which I have written in blue can be evaluated. So if you want the partial derivative of x, you should take a look at x and differentiate it with respect to u, and that means u is the only variable, so we are going to get e power u. Anyway, the differentiation is simple enough, but I'll ask you one question. What is the derivative of e to the power x with respect to x? I'm sure most of you know the answer. It's e power x. And what is the derivative of e to the power minus x with respect to x? It is e to the power minus x into minus 1 because of chain rule. It looks like e to the power something, and differentiating this minus x gives you minus 1. So please be aware of this. So applying those things, we get something like this. Okay, now I want you to take a very good look at the question. We want the difference. We found partial with respect to u, the partial derivative with respect to v. Now we have to subtract. I'll do one thing. I'll keep this on the top of the screen. Okay, once more, take a very good look at the question. Take a look at the left side of the question. It's the same thing which we found here, but we have to find the difference. So let's do equation 1 minus 2. So this minus this will be the left hand side, and this minus this, and that will make this quantity positive, and this minus this will make this quantity positive. So I have the answer. Once more, I want you to take a very good look at the question. What is e power u plus e power minus v? Isn't it x? Okay. And what about e power v minus e power minus u? Isn't it y? That's it. And that's it. So let's move ahead for the last application, that is with differential. So look at this. Suppose u is a function in two variables, let's say x and y. Then this notation, capital delta u, this is capital delta and this is small delta. Okay, so this notation refers to actual change, and this du, or some books follow delta u, is the approximate change which we find using calculus or the differential method. And remember, this method will be accurate if you consider very nearby points. Okay, I'm sure you're confused with these things. Let's do one problem and understand. So look at this. We have a function x squared minus 2xy plus 3y. So they're asking find the differential du. Like I mentioned before, when I see du, I remember, okay, I had to use calculus. And you have to find the actual change delta u. And remember, delta u means you have to apply the actual technique. And they are telling you xy changes from 1.2 to 1.03 comma 1.99. Remember, these are things in the 2 dimension. That's why it looks like this. So let's start. As always, I'll keep the question here, and the first thing we are going to find is the differential. I hope you have a screenshot of the formula list. So go for the third one. So u equal to f of xy, then the differential of u is given by this formula. And I want you to note one thing. Xy changes to x plus delta x, y plus delta y. I didn't give you the proof for the formula, but these things are from the formula. So remember, the original point, it's given, changes from 1.2 to to this. So remember, this is x plus delta x and this is x. So if you subtract, you will be able to find the value of dx. And if you subtract this, you will be able to find the value of dy. And I have those values over here. And hence we can fill this, and we want the partial derivative of f with respect to x. Anyway, the name is slightly different here, it's u. Okay, so what is the derivative of u with respect to x? I think in your exam it's better to make it u, because in the question it's u. So the partial derivative of u with respect to x is 2x minus 2y, and I have substituted the formula, this minus this. Okay, that's it. Now instead of x I'll put 1, and instead of y I'll use 2. Simplify. Okay, this is called the differential value. Okay, now look at this. We found this in a very easy manner because calculus was there to help. Now let's go for the actual method. So actual change is very easy. This is the initial point, this is the final point. So what we do is we plug in the final value minus we plug in the initial value in the given function. So I will write the initial value, final value over here, and look at this. I'm going to plug in the final value here, and see, if you compare the value which we got from the differential method, it will be very, very nearby. It's approximately 0.07. Okay, now let's do one more application. So look at this. We have a rectangular ice block, and rectangular ice block means it will have length, breadth and height. So initially the dimensions are 100, 50, 30, and after some time the dimensions became 99.9, 49.95 and 29.88. Yeah, it's because of melting, and for mathematical purpose they have given the shape has not changed. It's still a rectangular block. And one more thing is given, they measured these quantities in centimeters, and the order is length, breadth and height. So they're asking find the change in volume. So look at this, we have two options. If you want, you can go for the direct method, or you can do it with our differential method. Anyway, I'm going to try it with our differential method. So we have u is equal to x, y, z. Because they are talking about volume, I wrote the formula for volume. And then I'll mention x is length, y is width and z is height. And I'm going to calculate the approximate change. Remember, approximate change means differential method. And we have the formula. And this dx represents final point minus initial point. Okay, so that's it. What is the partial derivative of v with respect to x? Yeah, so you can plug in all those values and simplify, use the calculator. Yeah, that means we lost approximately 900 centimeter cube of volume. Okay, that's it. That's the end of the second lesson. Tomorrow we will discuss something very important, that is called Euler's theorem. And then afterwards we will discuss maxima minima, and that will be the end of the first chapter, which is like 10 marks. And once we complete it, we will start with multiple integrals, and in 2 lessons we will complete all the important parts. Okay, So I'll be back with a new video, and that will be lesson number 3, and I'll be back tomorrow. So till then, bye.